Hey guys, welcome back. Mr. Marone here. So this is our first video for lesson 2.2, which is kind of a unique section. So we've looked at these four angle pairs, corresponding alternate interior, alternate exterior, and same side interior. And now we're going to look at something called a converse, not the shoe that you all wear. And the converse is when you take a conclusion and a hypothesis and you reverse them. So before, we said that if we had parallel lines, if line A was parallel to line B, that all of these angle pairs were true. That, say, angle 1 was congruent to angle 5 in this picture. Okay, that was our corresponding angles. Now, we're going to reverse the process. We're going to show that it can work both ways, that if you have congruent angles at specific spots, you can say that the lines are parallel. So we have converses of all of these theorems that we're going to take a look at. And then the second vocabulary that's big for this section is the idea of a flow proof. They're not my favorite proofs to do, but they are kind of neat because they're just a little bit less structured and a little bit easier to work with. So we're going to take a look real quick at this idea that the converse is when you reverse hypothesis and conclusion. So here's an example that I wanted to point out, and then we're going to take a look at one proof and be ready to go with the rest of these converses when we get into class tomorrow. So in the original statement, it says that if I had two angles that are complementary, that their measures add to 90 degrees. You guys know that complementary angles equal 90. So that's our original statement. Now, if we do the converse of it, this right here was my hypothesis, my if part of it, and our then is their measures add to 90. If we reverse those, is the same thing still true? If the measures of two angles add to 90 degrees, then their angles are complementary. Yeah, that's true. So this right here is just the converse of what's being said here. We're just replacing our hypothesis and our conclusion. We're just swapping them. So our goal is to show for one of these, we're only going to do one, we're going to show the alternate interior angles theorem. We're going to write a paragraph to prove this. So they told us that angles 1 and 2 are congruent. That was the starting information. And they wanted us to prove that lines L and M were parallel. So what we're going to do here is work our way backwards, and we're going to use a flow proof. So they gave us that angle 1 is congruent to angle 2, and then just below that I'm going to write given. I'm going to circle those things, and it's given to me. Now, if we look closely at the information given to us in this picture, we have 1 and 3. We'd call them vertical angles, or at least I would. So we can say that angle 1 is congruent to angle 3. And those are vertical angles. Okay? Well, if angle 1's congruent to angle 2 and 1's congruent to angle 3, we can put those together, use both of those steps to say that angle 2 is congruent to angle 3. And my reason for that is the transitive property, or substitution. It's your choice, but I'm going to say transitive property. Okay. Since we know that 2 and 3 are congruent, those are known as corresponding angles. So we can say that since we were given these interior angles, and we ended up with corresponding angles, that we now have that L is parallel to M. Flow proofs might be your thing, they might not be. I just wanted to introduce them to you with something as simple as this, this quick proof here on the converse of the alternate interior angles theorem. So the neat part about this section is we now have 4 converses we can use. We can use them in both ways. If you're given parallel lines, then you know that the corresponding angles are congruent, alternate interior are congruent, and so on, but we can reverse that as well. If you're given alternate interior angles that are congruent, you automatically know the lines are parallel. It's kind of an abstract concept, so it's a little out there. If you have questions, bring them in tomorrow and we'll take a look in class. Have a great night, guys. Bye-bye.